need to validate opaque OAuth tokens in FastMCP without parsing JWTs or managing cryptographic keys. You'll see how to configure token introspection against your OAuth provider, where FastMCP securely delegates validation to the authorization server for every request. This approach works with any OAuth-compliant identity provider, including enterprise SSO systems that issue opaque reference tokens. From FastMCP, import FastMCP. From FastMCP server auth provider's introspection, import IntrospectionTokenVerifier. Hash configure introspection with your OAuth provider. Verifier equals IntrospectionTokenVerifier. Introspection URL equals https://auth yourcompany.com/oauth/introspect. Client ID equals MCP resource server. Client secret equals your client secret. Required scopes equals API read, API write. MCP equals FastMCP. Name equals protected API. Auth equals verifier. This demonstrates the token introspection pattern for delegated authentication in microservices. The approach treats your FastMCP server as a pure resource server that validates opaque tokens by querying an external authority, rather than performing local cryptographic validation. What makes this distinctive is the complete separation between token issuance and validation, enabling centralized authentication while keeping your service stateless. The pattern works by implementing the OAuth 2 introspection protocol, where your server acts as a client to an authorization service. When a request arrives with a bearer token, FastMCP makes an authenticated call to the introspection endpoint, receiving back the token's active status, scopes, and subject claims. This design maintains security through short-lived credentials and immediate revocation capability, while offloading identity management to specialized infrastructure. This approach matters because it solves the distributed authentication problem in microservices architectures. You avoid embedding cryptographic logic in every service, instead relying on a single source of truth for token validation. The trade-off is increased network latency for each validation, but the benefit is stronger security guarantees, immediate revocation capability, and simplified key management. It's ideal for enterprise environments where security requirements outweigh performance considerations. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI-callable tool servers. It handles the bridge between your Python functions and AI models, managing authentication, schema generation, and execution. From FastMCP server auth provider's introspection, import IntrospectionTokenVerifier. This imports IntrospectionTokenVerifier, an OAuth 2 token validation provider that verifies access tokens by calling your auth server's introspection endpoint. It handles the security-critical step of validating token authenticity and checking required scopes before allowing API access. Hash configure introspection with your OAuth provider. Verifier equals IntrospectionTokenVerifier. This instantiates an OAuth 2 token verifier using the introspection pattern. Instead of validating JWTs locally, it delegates to your auth provider's introspection endpoint, ensuring real-time token validation and scope enforcement. Required for production-grade OAuth 2 security. Introspection URL equals https://auth yourcompany.com/oauth/introspect. This specifies your OAuth provider's introspection endpoint. The server validates access tokens by calling this URL, converting opaque tokens into verifiable claims about the user and their permissions. Without this, token validation fails and all API requests are rejected. Client ID equals MCP resource server. This identifies your service to the OAuth provider. The cliented must match the registered credential in your auth system, enabling proper token validation and scope enforcement. Client secret equals your client secret. This is the OAuth 2 client secret for server-to-server authentication. It proves your API's identity to the OAuth provider, preventing unauthorized introspection requests. Always keep this secret secure. Exposure defeats your entire authentication chain. Required scopes equals API read, API write. This enforces scope-based authorization by requiring tokens to include both API read and API write permissions. The Introspection verifier will reject any OAuth token missing these scopes, preventing unauthorized access to protected endpoints. This is the standard OAuth 2 scope validation pattern for API security. This closing parenthesis finalizes the IntrospectionTokenVerifier configuration. It locks in the OAuth introspection settings, including the endpoint, credentials, and required scopes, making the verifier ready for use in FastMCP's auth system. MCP equals FastMCP. Name equals protected API. Auth equals verifier. This instantiates the FastMCP server with OAuth protection. The auth equals verifier parameter enforces token validation via the introspection endpoint we configured earlier, ensuring only authorized requests with proper scopes can access your API endpoints. This is the standard pattern for securing FastMCP services with external OAuth providers. OAuth introspection pattern. The IntrospectionTokenVerifier bridges opaque tokens and FastMCP servers by delegating validation to your OAuth provider, maintaining security without JWT complexity. Each introspection call adds network latency, so cache results judiciously in production. This pattern enables seamless integration with legacy OAuth systems while keeping your FastMCP server stateless.
The token that reveals nothing grants everything.